in all these things. As we have discussed, we have some category of data transfer function, arithmetic, logic, branch, machine control. Data transfer, which transfer from one location to another location, only data will be moved. Arithmetic, several variations are there: addition, subtraction, increment, decrement, logical, CMP, branch, machine, and that we have this what we have discussed. Say so. अभी क्लास वही क्लास में क्लास so we have taken this is for initializing the to make sure that a is 0 0. Okay. Hello. Hello. 04. This is D2, which is 04, which act as a counter. Okay. So this will add B, which is 0 to 4 times. The first time C will be 4 minus 1, which will be 3. Second time C will be 3 minus 1, 2. Third time C will be 2 minus 1, 1. And last time C will be 1 minus 1, 0. When Z is 1, or just this will be this will be actually n. Then oh no, so if Z is 0, result is not 0, that means C is not 0, it will go to repeat. And if R is 0, that means C is 0, Z is 1, it will go to this one. All. So after result, A will be having 0 8. This is what the concept is. So I am just saying that this level could be anything, but this should be same. It could be multi, it could be loop, then it will be also loop. If it is repeat, then it will also be repeat. Yes. Okay. Okay. Thank you. So next, say what happens when actually this is a sort of assembly programming, and this is actually when it is converted to hex code. So basically, this is a binary code. That means this is actually 0011. This is like this one. So this could be, it could start from 200, it could start from 300, anyone. Whatever the first location, that will be fixed by that one. It could be 200 or it could be 30. So this is memory location and this is code. So 2003E. So this whole will become MVIA00. This 2 will become MVIB02. This become MVIC04. This is one location. This will make add B. This is decrement. See, this is the code which can be seen by the. Now these three actually make JNJ2006. So that is why when multi is, when compiler or assembler see that this multi is actually 2006, it will convert this as to 2006. So this will be done actually when assembler or compiler, when it will goes through. So it, when it found that the add B is 2006 and this is the instruction which is level multi. So that will, this multi will be replaced by the actual address of the instruction. This is done. So you need not to change program. For example, suppose the program start from 3000. So automatically it will become 3001 and automatically it will become 3006 and this will become 0630. So that will be replaced by 3006 and 3006. So that is why the program is written using the label, because we do not know the actual address of multi. So that will be done at the level of compiler or assembler level like this. So this is important. So we write program using labeling, and and as we have taken in, suppose if we have uh, I1, I2, and if we have two loop 1 and loop 2, and if we have say jump Z loop 1 and jump Lord Z loop 2. So loop 1 address will be replaced by loop 1 both the places. Loop 2 address will be replaced by loop 2 both the places. So that is how the things will be done. So remember, this is assembly, this is, you can say, machine, but actual machine will be, this will be 00111110, then 2001 convert will be having 000, and then 2002 will be having 000011, and so on. So but this whole will make it jump on no zero 2006. Now say we have, that is why we have a concept of n byte instruction. That is, in processor we may have 1 byte instruction, we may have 2 byte instruction, we may have 3 byte, we may have 4 byte instruction, and so on. In general, we may have n byte instruction. But in 8085 processor, we have these three category: 1 byte, 2 byte, and 3 byte. 1 byte, 2 byte, 3 byte. But in other processor, we may have 5 byte or 6 byte instruction. What does it mean when we say this is 1 byte or 2 byte? If you we see the same this program, this is the program which add 05 plus 03. So what we do actually, first we transfer A to 05, then we transfer B to 03, then we A plus B will be added and transferred to A. In this case, you can see here, this is the memory location. This MVI A, just try to get it. This occupies two memory location, one this one and one this two. MVI B, this occupy two memory location. But add B, this occupy only one. So some instruction may contains two memory location. Some instruction may contains only one. Like say this one also, this contains two memory location. But this contains only one location. So the number of memory location taken by one instruction, that will govern how many bytes will be taken. So that is why MVI is that is why MVI is 2 byte instruction, and MOV is or for example here, add B is 1 byte instruction. This information is necessary for a designer because suppose if we write MVI B06 or MVI A06, uh, if we write, अगर इसको हम चेंज करें 06 एंड MVI 06, तो यहाँ पे हमको लिखना पड़ेगा 3E06 यहाँ पे 3 06 है तीनों, लेकिन दिस 06 इज फॉर MVI B. So this is instruction and this is of data 8 bit data. So this is not instruction. So processor must know that this is the one instruction and this is one instruction. So processor must know that this is one instruction, this is another instruction, then now this is one byte instruction. Only then it will know that this 06 is MVI B, but this 06 is 8-bit data or 8-bit operand, like this. So that is how processor must know that how many byte. And in memory location, this is say MVIA 05. 2 byte will be taken by MVIB 03. 1 byte will be taken by add B, and 1 byte will be taken by HLT. So that is why 1 byte, 2 byte, 3 byte. 3 byte instruction is this one. This is 3 byte because this will take 3 memory location if you see. 1, 2, 3 memory location is taken by. Generally the instruction which contains address, generally they are 3 byte instruction. So we have for 8085, for 8085 we have 1 byte, we have 2 byte, we have 3 byte. इसको यहाँ भी करेक्ट कर दें ये एक्चुअली 3 byte, 2 byte. So for 1 byte we have option like add B, move HLT. 2 byte like say MVI A. 3 byte like jump on no zero, jump on zero, jump, because all these followed by the address. So that is why we have a three instructions are there. Now say we take some instruction. 8085 is actually normally work on 8-bit operand, or but some instruction they work on 16-bit. Like say how what are those instructions? Like say LXI. LXI has actually whenever LXI, suppose if you write LXI D, or we could write LXI B, or we could write LXI H, if we could write LXI SP. Actually, when we write MVI A, then this will be followed by 8-bit data or operand. So we could write MVI A04. Suppose if you write MVI H20, and if you write MVI L50. So this is 8-bit and this is 8-bit. In LXI, we could write in both these two things can be equivalently written as LXI H2050 or LXI H2050. This is 16 bit. Remember, this is actually 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0. This 16 bit will be transferred to SI. So this will become 2 0 and this will become 5 0. When you write LXI D3040, then D will become 30 and this will become 40. If you write LXI B1122, this will become 11 and 22. And we could write LXI SP 300, so this will become 3000. So that is how the stack pointer can be initialized. This will be used actually to initialize stack pointers. So what happens? SP will be transferred with. So the instruction which generally contains X in 8085, they are generally followed by 16 bit, and which are MVI. So MVI 8 bit follow, LXI 16 bit will be followed. So these two instruction can be easily accommodated with LXI H2050. So LXI, and we will see that some instruction actually uses some instruction use HL pair, DE pair, and BC pair as a memory pointer because our memory is 16 bit. So memory is 16 bit, and if some register want to points to these memory location, this must contains uh, 16 bit. We will see how this will happen. INX, again this contains a X. So if you we have already familiar with, we could write say INRB, we could write INRA, we could write INRC, we could write decrement B. So what happens? B will be transferred with B plus 1. In this case, B will become B minus 1. Here X is written, so we could write INX B. In this case, BC pair will be incremented. So suppose B contains 00, C contains 00. So if you write say INX B, this has the effect 000 plus 1. This will become 001. And if you write say INRC, that have a effect of 4 6 8 bit 00 H plus 1H, that will be 01. So when we write say INR, only this will be considered. Suppose if you write say INR E contains say 1 1. So INR E, the operand will be this one. For INXB, the operand will be this one. This is the difference. When we have say INXB, the operand will be the 16 bit. So INXB inherently it is BC will be BC plus 1. And that will be similarly we can have say INX H. So HL pair will be increased by HL plus 1. So in this case, the operand will be HL pair. So that is how the INX or DCX. Similarly, DCX is also there. Uh, DCX. B means BC pair will be decremented by 1. So because our memory is generally for 16 bit, so if you want to increment memory, we can use say INXB. If you want to decrease memory, so INXB will reach here, DCXB will reach here, and that is how the things will be done. So generally these are the memory pointer, and they will be used as a memory pointer. And uh, also we have DAD. DAD is 16 bit addition. Remember when we have say add B, what happens? A will be modified by A plus B. Or if you write say add R, A will be modified by A plus register. This is 8 bit, this is 8 bit. What that does, it is if you write say DAD B, just to see carefully, HL pair will be modified by HL pair plus BC pair. So suppose if contains 0 0, this contains say 0 0, this contains 1 1, this contains 2 2. मैं इसको भी कर दे 0 1 0 1. So after DAD B, this will become 0 2, this will become 2 3. So this BC pair will be added. So in this case, HL pair will act as a 16-bit accumulator. So, however, otherwise we also have otherwise we have to write program to add 16-bit addition. But for the DAD B, we could write say DAD followed by register pair, and the effective HL will be modified the content of HL plus register pair. It could be BC, it could be DE, it could be HL itself. So DAD actually will uh, add 16-bit data or operand with the HL pair. So this is the extension of add. Add is for 8-bit addition, DAD is for 16-bit addition. Remember say 8085 is actually 8085 is actually 8-bit processor, 8-bit data bus, 8-bit ALU. So generally it performs all the operation 8-bit. Some instructions are for 16-bit, as we have discussed somewhere, like LXI, INX, stacks, LDX. They will be used for the 16-bit. Now say, what does this do? Stacks L. First remind you, uh, just remind you If you write say STA 2050, this means store accumulator to memory location 2050. So what happens? A contents will be transferred to 205. This is what STA does. This is the stacks. What we write here, stacks B. It will store accumulator A to memory location given by BC pair. So what happens? Suppose BC contains 3040, A contains 01. So after stacks B, this 01 will be transferred to memory location to this one, 01. This is memory location, this is data. So that is how the BC pair could be used here. Similarly, we could have the reverse of it. As we have in this case, we have LDA. LDA LDA is load accumulator. यहाँ पे कोई एड्रेस लिखा होगा फ्रॉम मेमोरी लोकेशन गिवन. LDX load accumulator from memory location given by register pair. So suppose if you write LDA X D and D contains 3050 and 3050 is suppose this one and this contains a FF. So if we execute LDXGA, so that will transfer this FF to accumulator FF. So this is LDAXD. And if we have say this is say suppose 4050, and if you write say stacks 4050 and suppose 4050 is this one, and then this will go to this is. So this is stacks and this is LDX. Now see the difference between move STX, no, move there are three categories. One category is move, second category LDX, and third category is LDA. Now see what the difference uh, among all these things. I just try to I just try to explain. When we write say move uh, MB, this will store B will be copied to memory location पॉइंटेड बाई एच एल पेयर. यहाँ हम कोई एच एल पेयर लिख नहीं रहे हैं, लेकिन ये अंडरस्टूड है. सपोज एच एल कंटेन्स 4050 and B contains 32. So when we write move MB, the content of B will be transferred to here 324050. This is move MB. So this will actually inherently use content of HL pair. Remember, and move MB has all the variation. Like we can have move AM, we can have BM, we can have CM, we have DM, we have HM, we have LM. Also, we have move MA, move MB, we have MC. So we can transfer from, this is the big difference. We can transfer from memory location pointed by HL pair to any register of CPU. This is the important thing for move. Move RM and move MR. Okay. When we have stacks, this will transfer content of accumulator to memory location pointed by BC pair. So suppose BC contains 3242 and A contains FF, and this is say 3242, then FF will be transferred to this one. So stack me, so this is an STA. इसमें हमको एड्रेस सीधे लिखना पड़ता है. वी हैव टू राइट STA 3242. It has the same effect. It will directly transfer A to 3242 memory location. So I do not know that whether I have made it clear or not. Just to remind that move depend upon HL pair, STX LDX, memory location, given by BC pair or D pair. And STA LDA memory location itself is given. तो इसीलिए यहाँ पे जो होंगे वो होंगे मूव AM, मूव CM, मूव MD, etc. All this M, whether they are source or whether they are destination, they are governed by the HL pair. यहाँ पे क्या होगा? stacks B, stacks D, LDX B, LDX D. In this case, memory location is governed by either BC pair or D pair. और यहाँ पे इंस्ट्रक्शन कैसे होंगे? STA 2050, STA 400, LDA 3242, LDA 2050. तो यहाँ पे हमको इंस्ट्रक्शन में एड्रेस एब्सोल्यूट देना पड़ेगा. यहाँ पे हमको एड्रेस नहीं पता, लेकिन जो BC पेयर में है उस मेमोरी लोकेशन से ट्रांसफर होगा, जो D पेयर में है उससे ट्रांसफर होगा. और मूव में जो HL पेयर में है उससे ट्रांसफर होगा. So these are some instruction. There is no instruction in 8085 particularly. In suppose, this is for example, we have move RM and move MR. इसमें M सोर्स है, R डेस्टिनेशन है. इसमें R सोर्स है, M डेस्टिनेशन है. मतलब इसमें मेमोरी लोकेशन से R में जाएगा, इसमें R से मेरी लोकेशन में जाएगा. या इसको मैं से लिख दें. इसमें M से आ जाएगा. In 8085 we do not transfer memory to memory directly. So we cannot transfer it by, we do not have any, that is, this is not possible that we could write move MM. This is not possible. So we cannot transfer data from memory to memory. That is, we can transfer, but we cannot directly transfer because we do not have any instruction in 8085 which can transfer data from memory to memory directly like this way. So, but memory to register can be transferred, register to memory can be transferred. So, suppose if we have 2050 and we have FF, and at C050 we have 00. And if we want to transfer this data to, suppose here, so we could write LDA 2050. So this FF will come here, and after that we could write STA 3050. So this will erase and FF will come. So one instruction will use LDA 2050 and one instruction is STA 2050. So then this FF will be transferred to this location. But we do not have any instruction which can directly transfer the data from this place to this place. So we should finish here actually. So we have the data, arithmetic, logical, CMP branch, and these are the sub instruction uh, which basically work on 16-bit operand. Like LXI, uh, we could write say LXI H increment, decrement X, like that. And we have some more instruction, but these are the most useful, more useful. LXI is often used an increment HL pair like this one. So all these work on 16-bit. So we should finish here. Okay, thank you.
Thank you, sir.
Okay.
Thank you, sir.